You know, in a microservice solution, we have many applications running together, communicating with each other to provide a unified application experience for end users. When it comes to developing such a solution, we have difficulties for running the entire system in our local environment to test what we have done, how it works in the voice system, or debugging a service to trace a problem. With ABP Studio Kubernetes integration, it's pretty easy to get the system up and running in a Kubernetes cluster while we can run a single service or application in our local development environment and then tie these environments together so they work as a single system. In this way, we can run, test, or debug our services easily in a complicated microservice solution. In this video, I will demonstrate how it works. I have already created a sample solution with ABP Studio. You can see the solution. We have some applications, gateways, some services, and so on. We have especially catalog service and ordering service here. This solution is not deployed to Kubernetes yet. We will first deploy to Kubernetes, then make some development and see how it works with Kubernetes integration. To demonstrate it, I'm using the kubectl with get all objects in my namespace, and you see that there is no object found in this namespace. I'm going to the Kubernetes integration tab of ABP Studio. Here we see a Helm tab and Kubernetes tab. Helm charts are used to configure Kubernetes, for an application or for a multi-application solution easily. I can right-click the charts and select the build Docker images first. Because for my all applications and .NET services, we need to create Docker images to be able to deploy to Kubernetes. I am waiting a while the ABP Studio prepares all the Docker images for all my services. Okay, finish it. Now I can go to the Helm chart tab again, right click and select the install charts command. Now it's installing the charts to Helm. It's very fast because Helm only makes the Kubernetes configuration and Kubernetes tries to start the services internally. Let's execute the same kubectl command again to see the services, pods, and other objects in Kubernetes. You see, some of the pods are already ready, but some of them are still running and starting. After waiting a while, we can check it again. Now I can see all the services are ready and started. I can browse the application on my browser. This is the web application. When I click the login button, I'm redirected to the authentication server application. I'm logging through the login panel. Then here I see some page coming from the pre-built modules that are running as microservices in Kubernetes. These modules are coming from ABP platform's pre-built modules. For example, in the role management page, I can set permissions of a role. You see, not all permissions are granted yet. I can grant all the permissions, refresh the page. Now I can see a products page and an orders page. Products page is communicating to the catalog module, catalog microservice, sorry. I can create a product A and the product B as an example. And then go to the orders page, which is communicating to the order microservice. Create a order for product A with, for example, 500 stock count. You see, if there is no stock count for the given amount, it throws an exception. I can just order 5 items. When I go to the products page again, I see that the stock count has decreased to 95 because the order microservice publish an event and the product microservice gets it and decrease the stock count. Okay, now I'm returning to the ABP Studio, going to the Kubernetes tab and clicking the connect button. This connect button actually establishes a VPN tunnel between our local development environment and with the Kubernetes cluster. In this way, we can reach all the services even if they are not deployed, they are not exposed to out of the cluster. We can reach all the services, even databases and so on. It takes a little time on the first connection. In the second connection, it will be faster for the same cluster. Okay, it's connected, and we can see all the services here. Like for example, some internal services like SQL Server or catalog microservice or ordering microservice and so on. As I said, even internal services like for example, SQL Server is not exposed to out of cluster. However, after connecting to Kubernetes, we can connect to the SQL Server database that is running inside Kubernetes. We can explore the databases. You see, for every microservice, there is a corresponding database has been created. After connecting to Kubernetes, I can also right-click a service here, for example, right-click to a catalog service and browse the application. You see this service is also not exposed to out of cluster normally, but we can access because of the VPN tunnel. We can see products, HTTP APIs or ordering, or we can browse the web application inside the pre-built browser of ABP Studio. Let's log in the application inside the ABP Studio. So in this way, we don't need to use an external browser. We can see the same orders, products. For example, I can create a new order. I can go to the products. It decreased the stock count because you see, from the ABP Studio, we have a monitoring area. We can monitor all the services and applications. We can see all the HTTP requests, for example, this post request for the creating the product. You see, we sent customer name to some JSON post to create a new order. We can go to the events tab. Here we can see this event, like order placed event has been sent from the ordering microservice and received by the catalog microservice, and the stock count has been decreased. All the communication, including HTTP requests or distributed events, can be traced with the ABP Studio. Also, we can see exceptions here. For example, let's return to the products and try to create a product with the same name. You see, we get an exception here. We can see the exception details, stack trace, even inner exception in the ABP Studio exceptions window. So we can easily understand what is happening in our cluster. We can even see logs for each application or service, or even we can use the tool window to see the user interfaces of the tools we are already using, like Grafana, Kibana, like Prometheus or RabbitMQ UIs. It's not topic of today. Let's return to browse. Now I want to make some development on the catalog module. I don't want to throw exception anymore. instead I add a number of to the end of the name while creating a existing product name. To do that, let's first see that catalog service is running. Okay, that's good. I can open the catalog service in my Visual Studio, for example, because if I need to make some code change, I need to use my IDE. ABP Studio is not a coding tool. Here you see the code. It checks an existing product with the same name, and if found, it throws an user-friendly exception. Otherwise, it creates the product. Let's add a breakpoint here. But you know, when we use the application, now all the requests are going to the catalog service that is running in the Kubernetes cluster. But when I do that, go to the catalog microservice and enable interception. Now all the requests coming to the catalog microservice is redirected to my local computer. To prove it, first I want to show that if I refresh the page, it will not work anymore because this service is not working in my local computer yet. And let's make it working in debug mode. Okay, now it's working. I'm returning to the ABP Studio and refreshing the page. Now you see it's working because the response is coming from my local computer. To prove it, let's save the dialog that from the web application that is running in Kubernetes. So when it makes a request to catalog service, the request is redirected to my local computer, and in my local computer I am running the catalog service in debug mode in Visual Studio, so I can hit the debug, check if an entity exists, and throw an exception. You see that we are throwing the exception here. Now I want to make a development. Instead of throwing an exception, I want to just add a random name to the end of the product name, random number between 1000 and 2000, for example. At the breakpoint again. Normally I need to restart the application because I changed the C# code, it need to be rebuilt and so on. But yeah, since I can use the hot reload feature of Visual Studio, I can just click this hot reload button, and now it is deployed. It's applied to the running application without stopping it. Now I go to the application again, press the save button. Here you see, instead of creating a new, so instead of throwing an exception, I am adding a random number. So you see, it's added to the end of the product name. Now I complete my development. I can stop the service, go to the catalog module, right click and disable the interception. When I disable the interception, the request now returns back to the original one. When this web application works, it sends request to the service, catalog service that is running in the Kubernetes cluster. So when I save, so old behavior we see, we are getting an exception here because this new code hasn't been deployed to the Kubernetes yet. Let's make it. Right click to the catalog microservice, select the redeploy command. It will take a few seconds because it will build the service in release mode and deploy to the Kubernetes and so on. Okay, it seems redeployed. When I click the save button, Now, instead of getting an exception, it creates another product with the same name with a random number added to the end. When I finish my development, I can disconnect from Kubernetes cluster and I'll finish it.